The title of my presentation that we're going to be going over today is DevSecOps for the Community, Building, Provisioning, and Deploying CVE's Infrastructure and Services. So let's get started. Just a brief agenda before we really dive into things. I'm going to cover a little bit about who I am, my personal work experience, as well as my education. And then for any of those who are dialing in who aren't familiar with the CVE program, I'm sure it's safe to say that most people are, but just in case there's anyone who isn't, we're going to talk about a little the history of CVE for a brief time, and then where these systems come into play to support the CVE community. And then before we start diving into the technical implementations of the two primary systems that we're going to be covering today, I really want to talk about the DevSecOps culture that we've implemented and really try to champion, not only on the CVE team, but within MITRE. Once we finish up with that, we're going to talk about CVE Services, which is the newly deployed set of APIs that allow CVE numbering authorities to edit and submit and publish new CVE information, as well as the new CVEorg beta website. And then to wrap up, we're going to talk about some future DevSecOps improvements that we have in the horizon that we'd like to get implemented. So just a little bit about myself. Like Joe said, my name is Shane Ficorilli. I was born and raised in Pittsburgh, Pennsylvania. I have a Bachelor's of Science in Information Technology and a minor in Computer Science from La Roche College, which is a small school about 20 minutes north of Pittsburgh. And I also have a Master's of Science in Information Security Policy and Management from Carnegie Mellon University from the Heinz College. Professional experience-wise, I worked at the Software Engineering Institute for a total of about 7 years, 3 as an intern and about 4.5 full-time as a DevSecOps and software engineer on Joe and Hassan's team. So it's great to be back and to interact with some old faces, and be back with the old gang. And then in 2001, I started working as a senior cybersecurity engineer with MITRE Corp, so another FFRDC similar to the SEI. So some background on what the CVE program actually is. For those of you that aren't familiar, CVE stands for Common Vulnerabilities and Exposures. And the mission of the CVE program is to identify, catalog, and publish helpful information concerning all publicly disclosed cybersecurity vulnerabilities. So if there's a cybersecurity vulnerability, it will get assigned to CVE, and then that information is published and put out to the public so that everyone can consume it and patch systems or do whatever with that information that they need to. There's one CVE record for each vulnerability in the entire CVE catalog, and these vulnerabilities are discovered, assigned, and published by CVE numbering authorities, or CNAs, that have partnered with the CVE program. So for example, MITRE is a CNA, the Software Engineering Institute is a CNA, Google, Apple, Microsoft, just to name a few. The CVE program was launched to the public in September of 1999, so it's been around for a while. And all of the systems, the ones that we're going to be covering today, are owned and operated by MITRE. So the main systems we're going to be talking about today are really a system of systems, and this is just a general kind of a rough architecture of both CVE Services, which can be seen in the center of the slide within the dotted line, and the CVE program website, which can be seen in the tan block directly beneath that. So the CVE Services is essentially the cornerstone of how CNAs and researchers are interacting and publishing with existing CVE data and publishing new CVEs. They're a set of REST APIs that are deployed in AWS that can be consumed by CNAs or registered users. And then that information can also be consumed by the CVE program website, which is used by general users in the InfoSec community and researchers. So once all of this information is input to the CVE repository, either via a web form on the CVE website or through the CVE Services API, it is then uploaded to GitHub in JSON 5.0 schema, where it is then available and accessible for download to a list of CVE users downstream, and then they consume that data and use it in whatever way that they may also need to. So like I said, CVE Services is really the cornerstone of how CVE information is uploaded and manipulated. So before we dive into the technical implementations of our CI/CD and our DevSecOps processes, I really wanted to take a moment to talk about the DevSecOps culture. So, in my time at the SEI, I spent a few years being one of the instructors for the DevSecOps process and implementation course, and everyone is always so excited to jump into the technology and the tools that they actually get to use to implement their CI/CD pipelines and their automated testing and actually building and deploying out their services. But at the end of the day, it's really human beings that are working together to build, deliver, or deploy software securely. So within the CVE program and within MITRE, our development and security operations teams really do work very closely together. We're always on the same page, whether it's implementing new features, tracking our effort, overseeing deployments, and responding to any alerts or monitoring notifications that we get. So we really have worked hard to try to bring all of our subject matter expertise to the left and shift that expertise left as early in the software development lifecycle as possible. Specifically security, treating that as a first-class citizen and making sure that security requirements for all of these systems that we're deploying are just as important as our functional requirements. And in addition to our internal MITRE teams, we also have awesome community involvement and feedback from a few working groups that we have within the CVE program. So there are several more working groups within the program than what I have listed here, but the two primary working groups that are responsible for developing requirements and giving feedback for CVE services and for the website are the automation working group, the AWG, and the website working group, the WSWG. And the MITRE internal teams meet with these working groups in addition to the other ones every week to keep our customers, their feedback in the loop and to be able to implement any changes that they may suggest or, have those types of conversations. So diving into CVE services. A little bit of background about what CVE Services is, in addition to what I explained in the architecture diagram. It's a web addressable application to be used by CVE numbering authorities, or CNAs. It's comprised of a series of REST APIs for CNAs that their clients will use to actually connect to and perform functions such as reserving a CVE ID, submitting or updating a CVE record, or managing the CVE services users for a specific CNA, so creating accounts and changing passwords. And this allows for an instantaneous automatic response within the CVE repository and doesn't require any human intervention or lag time. So the CVE services source code itself lives in a public repository on GitHub. But all of the infrastructure that is created using AWS CloudFormation templates is stored in MITRE's internal GitLab instance, since we are the actual owners of these systems, and paying for those services within AWS. So keeping the application source code on GitHub allows the community to submit pull requests or merge requests and to also provide feedback, during the weekly syncs, as I had mentioned previously. So for CVE services, we currently have 5 different environments that exist in AWS. Here's a brief diagram kind of showing, the separate environments that we have. At the top, you can see that the actual infrastructure as code is stored, as I mentioned, in MITRE's internal GitLab, and this is built and provisioned in AWS. And then the CVE services source code is stored on GitHub. So in addition to all of the infrastructure in AWS that's required to host and serve up CVE services for all of these environments, all of the infrastructure as code to build out the CI/CD process is also a part of our CloudFormation templates. And one of the cool things about CloudFormation is that we're able to parameterize all of our environments, which allows us to be able to reuse a tremendous amount of our infrastructure as code. So we're able to use the same infrastructure as code files by passing in environment parameters for our development environment, integration, test, prod staging, and our production environment. So if you take a look at the diagram, our development, integration, and prod staging environment are the 3 environments that are internal to MITRE. They're used by our development teams to push code throughout the SDLC and for internal testing. Our testing environment and our production environment are available to the public, and our testing environment allows CNAs and other customers to be able to give us feedback on code before it makes its way further down the deployment pipeline. So taking a little deeper look into the actual CI/CD architecture, we are using several services within AWS to do so. As I said before, the source code itself is stored in a public repository on GitHub, but we're using AWS Code Pipeline, Code Build, and Code Deploy as our primary deployment services within AWS. So within each environment's code pipeline instance, and remember, as I said before, all of our infrastructure as code environments are parameterized. So the development environment has its own CI/CD pipeline. The integration environment has its own CI/CD pipeline. So for example, within the development environment's code pipeline, it is polling the development branch on GitHub for changes, and so on and so forth. The integration environment's code pipeline in AWS is polling the integration branch on GitHub for changes. So whenever there's a successful merge request on GitHub, that is what actually initiates the CI/CD process within AWS. So code pipeline pulls down the source code from AWS or from GitHub. It's then stored in S3 and pushed over to AWS Code Build, which then builds an actual artifact. That artifact is then stored in S3 and input into Code Deploy, which in CVE Services case is a Docker container. This container image is then deployed to our internal Elastic Container Registry, and then from there is deployed to ECS, which is the Elastic Container Service, as a Fargate task. In addition to the CI/CD tools within AWS that I had just mentioned, we're also doing a few things on the GitHub side, specifically for security. We're taking advantage of GitHub advanced security tools by using Dependabot scans and alerting to monitor all of the dependencies that we're using within the CVE Services source code, as well as using CodeQL static analysis scans to give us alerts for any potential vulnerabilities within the source code that may occur during development. And covering the services that were in the previous slide, we're using Code Pipeline, Code Build, S3, ECR, and ECS. In addition to those services, we're using a few other ones that actually support the infrastructure itself. We're using DocumentDB, which is AWS's flavor of Mongo. We're using EC2 virtual machines to act as bastion hosts to access our DocumentDB instances. And for those images, we're using MITRE vetted Amazon Linux 2 AMIs. We're using Application Load Balancer, VPC, IAM, CloudWatch for logging, as well as WAF for firewall rules. So pretty standard services within AWS that we're using for our cloud infrastructure. So moving on to CVE.org, the new beta CVE website. So as you can see here, the old and original website for CVE could be reached at cve.mitre.org, and this is still currently hosted on-prem by MITRE, but as you can tell, it was in desperate need for a facelift. So a screenshot in the next slide shows a picture of the homepage of the new website, which can be reached at cve.org. This website is hosted by MITRE-owned AWS infrastructure, similar to CVE Services. So this new website was developed with a modern web framework, and as you can tell, has a much more modern look to it. The CVE website is essentially a static website that is a consumer of the CVE Services API to dynamically generate content for CVE records that are searched for and displayed on the CVE website's front end. The CVE website source code also lives on a public repo on GitHub, and similar to CVE Services, all of the actual infrastructure as code with AWS CloudFormation is stored on our internal GitLab instance. There's one less environment for the website than there is for CVE Services, so there's 4 in total, and all of the website infrastructure exists within a separate AWS account than all the CVE Services infrastructure. So similar to CVE Services, this diagram shows the separation of our environments. As you can see from before, our infrastructure as code is stored in GitLab. And then the actual CVE application source code is stored on GitHub. We have a development and an integration environment that act as our internal environments for our development teams to be able to develop and deploy to and test on, and then as well as a testing instance that we can use to get feedback from the CVE community, and then of course the production instance, which is our CVE.org website. So here's another image similar to the previous one that may look a little bit the same. We are using a few of the same services, but the architecture of the website is a bit different because it's not using a container image and it's just static files that are deployed. So in a similar way, our AWS code pipeline is polling specific branches for each corresponding environment within GitHub. So the development environments code pipeline is pulling development, and integration is pulling integration, and so on and so forth. So whenever there's a successful merge request, code pipeline will pull down that source code, put it into S3, and then that is input as an artifact into code build. Now the artifact that's produced in code build for the website is the static website content that is then built and deployed to S3 and then consumed by a CloudFront distribution to be able to serve up that web content. So for the website, we're also using GitHub Advanced Security Tools. We're using, again, Dependabot scans and alerting for all of our dependencies, and we're taking advantage of CodeQL static analysis scans to get those results as well. And we're using Code Build, Code Pipeline, S3, and CloudFront as the primary services for our CI/CD components. There's a few other website components that we're using within AWS that we're not using within CVE services. For example, we're using CloudFront, we're using API Gateway, Route 53, the simple email service for a new feature that we're actually going to be deploying probably within the next year or so, and then as well as Lambda. And for any Lambda functions that we include, they also undergo static code analysis and review by MITRE's internal information security team. And I'm sorry, I misspoke. The newsletter functionality for the simple email service will be out within the next month or so, not year. So moving forward, some DevSecOps improvements that we would like to make that we have, kind of within our sites. We would really like to implement a dynamic application security testing. Currently, for both CVE services and for the website, we don't have any DAST solutions in place. So we would really like to be able to take advantage of automated pen testing within our CI/CD pipeline using tools like either Burp Suite or OWASP Zap to be able to integrate that feedback to our development teams and MITRE's own internal information security team as part of the development process. Next, we really want to focus on improving our monitoring strategy. We want to beef up our AWS resource monitoring, and as well as try to combine a lot of the internal security and network monitoring that MITRE is already doing on their end. So we can really have that in one centralized place, so we don't have to go to several different locations to gain or access those metrics. And finally, and last but definitely not least, we really want to try to focus on our DevSecOps metrics. So for example, the number of deployments, deployment frequency, mean time to recover, and other metrics of that nature to be able to try to improve our overall agile development process. And I believe that is it. We can move forward to questions. And I also have some references at the end here, the 2 GitHub links to the CVE services and website source code. If anyone is interested in contributing, they are completely open source, so we encourage the community to get involved, and as well as just some more in-depth overview of CVE services on CVE.org. And I have my contact information at the end here. And anyone is always more than welcome to reach out to me either via my MITRE email or on GitHub or on LinkedIn, and I'd be more than happy to chat and answer any questions.